So let's look at example 4 where it says how many 8-bit strings have exactly 3 ones. Okay, so in this case we have an 8-bit string, and what is it exactly that we have to do? Here's what we have to do. We have to select 3 of these places and put 1s on them, and the only other choice is 0. So once you figure out which 3 locations, let's say this one, and that one, have a 1, automatically the other 5 locations will become 0 instantly. Okay, so that's not, rocket science. It's either a 0 or a 1 because you're working with binary. So let's try a different scenario. What if I said I want the first 3 to be 1s, then automatically the other ones become 0s. So what am I ultimately doing? I'm ultimately selecting the places where the 1s go. So there are basically 1, 2, 3, 4, 5, 6, 7, and 8 locations, and all I'm doing is selecting which one of these locations will get a 1, and then automatically the rest of the locations will get the 0 right away. Okay, so I am selecting, so select 3 positions out of 8 possibilities, out of 8 possible locations. So it's kind of like similar to selecting 3 players out of 8, or selecting, 3 people to play on a group, in a group of basketball players of, out of 8. So it's the same kind of idea. So the total is going to be 8, choose 3. Okay, so that's how many there will be. Okay, again, once you select which locations have the 1s, then you're pretty much done. The other locations automatically get 0. I don't even have to worry about the other locations, right? It cannot be anything else. If I select these ones to be the 1s, automatically the other ones become a 0, okay? So 8 choose 3 is gonna be 56. So there are 56 8-bit strings with 3 1s, okay? Now, you could start the problem by selecting where the 1s go, and automatically you get the 0s, or the other option is select where the 0s go, and automatically you get where the 1s should be. So this is another way of counting the problem. So this would be considered, let's say, method 1. In method 1, you figure out where your 1s need to go, and then the rest of them will automatically become 0. In method 2, you select where the 0s go, and you will find out where the 1s end up. So method 2, select where the 0s go. So method 2, select the places where the 8, so you have 8 positions, and you select where the 0s have to go. So select where 5 of the 0s will go. So 5 positions out of the 8 possible locations. Okay, so in this case we end up with 56 again, because again, regardless of where you put the 0s, if you select where the 5 0s will go, then automatically the 3 positions that are left will get the 1s right away. So again, it does not matter. There's some sort of symmetry that's going on here. As a matter of fact, we're going to take advantage of that symmetry when we get to the next section and talk about the binomial theorem and Pascal triangle and all that stuff. Okay. So again, in method 1, I put the 1s first in the 8-bit string, and in method 2, I put the 0s first, and then I figure out where the 1s go. Regardless, though, the answer is going to be the same at the end.